Here's our principle in pneumatic. So physical principle in pneumatic means that this is the fluid power. Fluid power means that or air or the air gas or they are utilized in the industry. Especially the industrial system. The pneumatic system is more powerful than the electric because pneumatic does not need any electrical heating. If you use the electrical system, it will use losses of heating. Pneumatic is more powerful. So we use pneumatic. So before going through the pneumatic system, just flow the freely and they call the fluid. Fluid is divided as a substance which changes in shape easily and adapts to the shape of its container. So this means that the shape of the fluid is depending on the shape of the container. Another one is the fluid principle means that when the force is applied at one stage, both forces are equally spread. So this is for the container here. This is piston. So we put this piston. This is piston. So we put the piston here. When you put the pressure, those pressures will go easily. So they will separate. So this follows the Pascal law. When you put the pressure F1, this direction also F1, this is F1, this is F1, this is F1, F1, and F1. So F1 can be multiply. So multiply all the direction force are we going to the different direction. They also got the space the force F1. So by the way we use the liquid and most powerful. So when you want to use the hydraulic jet is we use the liquid. Liquid means that this is a small piston here. This is force. And this one will be the last piston. So this is the force upwards. You put the F1 is not separate force they are separating so that these called the things are equal force. All direction force are directed to this direction. So here only one F1, they are separate F1 here. So this can be the lift. So this is why in the process control system, we extensively use the pneumatic pressure. So we use the air pressure or we use the fluid pressure to perform the industrial task. So this is why we need to measure the pressure measurement, force measurement, mass measurement are the important aspect in the process control system. Pressure and the fluid pressure. So air pressure and fluid pressure are widely used in the industrial process control system. The measurement of pressure, force, mass, and density is the important aspect of the industrial process control. So this is why we have to measure how to measure the industrial process flow. So before going through the system, firstly we measure the force. So you have to measure the force and also you have to measure how the fluid transmission. So firstly we talk about the transmission of force by the fluid. First the Pascal law. The transmission of force by the fluid. When the one end of the bar of the solid is struck, the main force of the blow is transmitted straight through the bar to opposite end. So it is transmitted at the angle different to the direction of blow. Especially in the fluid, when you put the one force direction, the force directions are equal force. They are spread in the different direction. The force spread in different direction with equal magnitude in the fluid. So this is called the Pascal law. So we utilize the Pascal law in the industrial pneumatic control system. So because of this one, both forces are the air pressure or the water pressure or any hydraulic pressure. Those pressure need to be measured. So because of this one, firstly we have to find the pressure area. The pressure is equal to the force divided by area. So then we can also calculate force is equal to pressure multiplied with area. So in this case, our force will be the Pascal and Force will be the Newton, pressure with the Pascal, and area with the meter square. The force, the unit will be the Newton for the thing. And the pressure, the unit will be the Pascal or the Newton per meter square. The area, the unit will be the meter square. So those are the unit of force and the pressure. So we can calculate force by this equation. So area also depending on the area. Area is we have to use as a mensuration to measure the area. Just count this is for the this is the H and then this is B. So this is A equal to B multiplied H. So this target, this is diameter is D. So area is a pi D square by 4. So especially the most of the industrial area we use the either circular or the rectangular shape. We can calculate by the area by this way. So then also we can also calculate the force. The force is the multiplication of mass and acceleration. So force is equal to mass multiplied acceleration. So force is F, mass is M, acceleration E. So 4 unit will be the Newton, and unit will be the kilogram, a unit will be the meter per second square. And also we can also calculate the gravitational force. So gravitational force is a mass multiplied gravity. In this case, m is equal to mass. So kilogram and g is the gravity. So this is the 9.8 meter per second square. So this is for the gravitational force and the force that we can calculate by this way. So that this is the measurement of the force. The hydraulic lift. So in the hydraulic lift system, we use the hydraulic to lift the heavy machinery. So hydraulic is we can also use the crane system. We use the industrial hydraulic lift. So we talk about the industrial hydraulic system, how the hydraulic lift working. The industrial hydraulic system, this is the piston. When you put the piston, the all of the fluid. Those fluids they are pressed that are lifted this one. So when you put this is according to the Pascal law, all the fluids will go to here and those forces will lift the thing. Lift and the 660 kilogram will be the move upward. So because of this one, in the above diagram, is the pressure one, is the force 1 Newton. The force 1 Newton is applied to the piston with the 0.5 meter square cross-sectional area to the lift. To lift the 360 kilogram, what will be the diameter of the lift? So you have to find the diameter of the lift. So this is normally we call it a circular shape. That's why it's a circular shape. So according to the Pascal law, this piston force will be the F1. So F1 and then once the lift force will be the F2. So we apply this one with the F1. And area will be A1. And this is will be the F2, area will be the A2. So F1, A1, F2, A2. So in this case, we can use the pressure 1 is equal to pressure 2. Pressure 1, the piston, is equal to pressure 2. Lift. So this is the P1 is equal to P2. Pressure is equal to the force divided by area A1. This is the force divided by area A2. So have to be calculated. Okay, force 1 is already given the 1 meter. Area A1 is 0.5 meter square. And every is 360 kilograms. So we have to multiply with the 660 multiplying gravity G. So 9.81 by 1 Newton is a 0.5 multiply 660 into 9.81. So A2 is equal to 330 multiply 9.81. So these are the multiply 9.81, that will be the A2. So this one is this program here. I explained to you. So this is the piston. We put the piston on the area A1. So that this pole is multiplying the fluid, and then F2 will use a lift. So the area A2 is greater than A1. So although you apply this at 1 Newton, the outputs are load 360 kilogram can be lift. So the approximate is a Pascal law. Pressure 1 on the piston is equal to pressure in the lift. So P1 is equal to P2, F1 by A2 is equal to F1 by A1 is equal to F2 by A2. So there, F1 is W 1 Newton, A1.5. F2 is 360, and you have to multiply with gravity. Then you got the A2. So this is the hydraulic jet system. So you can if you utilize the larger area to carry the load, you can more force can be laid. So similar to the hydraulic jet or in the car workshop, you see the hydraulic jet. Hydraulic jet means the big piston is carried the small motor. They compressing the hydraulic fluid. So those hydraulic fluids are multiplied in the other larger lift. So this is the weight, the lifting the hose are carry the load down. So by this way we can multiply the force. So this is why the process control system, the force and the pressure measurement is an important aspect. Pressure drop. So this is any liquid or the water or any hydraulic gas, they are the flowing. This is hydraulic fluids are flowing. So this direction. So then we use our pressure way higher. For example, this one we use the pressure we use for example this 700, and then we use this one is 400 like this. Then we use when there's a flow here. This is a flow direction. Below the pipeline, there will be some friction. So this is friction. Now because of friction, when there's an other end of the pipe, there will be no longer the original pressure. For example, original pressure is 700 pascal, but end will be around the 200 pascal because the friction alone. So this friction is depending on the area, depending on the surface roughness, depending on how many pens. That depends on surface roughness, shape, number of pens, and the area of the pipe. So this one determines the friction. So this is for the flow and the pressure measurement. So long as the flow, there is a pressure is equal. So in this pressure P1 is equal to P2. So long as the flow is flowing. So P1 greater than P2. If there is a no flow, this one will be the P1. So this is no flow. So in this case P1 and P2 will be the same. No flow means P1 and P2 will be the same. So P1 equal to P2. P1 and P2 magnitude is a difference. So P1 is greater than P2. Okay. So long as the fluid is flowing in the pipe. When there is no flow, then P1 is equal to P2. Okay. So this is what we can utilize the pressure gauge to measure the pressure in the pipe. So now this is for the flow. So in the industrial system, we need to regulate the flow. In this case, in the easy example is in the your water tank. Water tank called the water bar. So water bar you can adjust the water bar. So similarly in the industrial system, we utilize the appropriate control bar. The control bar is also called the orifice. Orifice means this is how we utilize it. This is a pipeline. Pipeline is a smaller area and larger area. This is called the orifice. So all the pressure can be regulated here. So this is all the flow in any direction force will be concentrated into the one direction. So this one direction you can now adjust. So this is you can adjust by the adjustable bar. So this is for the bar. So this is the gauge. So this is the key bar. So in this case, this direction also will be going to this direction, and after that they will be expanding to this direction. So the all are compress and the expand. So this area will be the compression, and this one will be the expansion. So So due to the compression expansion, it can also affect the volume, pressure, and the temperature. So long as when the gas is expanded or compressed, it can affect the pressure, affect the volume and temperature. So there's a law, Whitelock and Charles law. The combination of Whitelock and Charles law we utilize to the compression and the expansion of the gas. So in this case, we can utilize the White and Charles combination law. The function is P1 V1 by T1 is equal to P2 P2 by T2. So P1 is the pressure 1, P1 P2 is the pressure. In this case, you use the Pascal or Newton per meter square. And V1 V2 is the volume. So you label the meter cube. T1 T2 is the temperature. So degree Kelvin. So in this case, T is equal to 273 plus T. So T means that degree C. So those things are the equations to utilize the Whitelock and Charles law. The reason is, in the industrial control system, we use the orifice and the K-bar, so that all the whole pipelines are all the whole pipelines are all of the water or the fluids are going, and they are concentrated to the one particular pipe, and we attach the K-bar. So that when the gas or fluids are they are compressing the expansion. So those compressing the expansion can create not only create the volume, change on the volume as well as the change on the temperature. This means the change on the temperature affected because this portion, for example, this point A, point 1. Your temperature may be that normal air temperature, for example, 20 degrees centigrade. But when this one is compressed, temperature will also be changing. So when the temperature change too much, sometimes this temperature can damage the bar. So bar must withstand the appropriate temperature. So although at the point 1 temperature 20 degrees centigrade may be sufficient, but when this one is passing through the bar, its temperature will be higher. So higher means the bar must withstand the bar material must withstand the appropriate temperature, which is right. And this is why we also need to measure and calculate apply the White and Charles law, how the fluid and fluid expansion and compression influence the volume and temperature. So when the gas or fluid is compressed or the expanded in a particular point, its pressure, volume and temperature will change. The use of material is required to be appropriate to such change. This one is flow through the orifice through the atmosphere. So in this case, especially we use this kind of compressor system. Compressor is utilized in the industrial system. One thing is that you use it instead of cutting especially the cutting any metal, where you use the compressed air. So compressed air, you use the compressed air as a cutter. This is the thing we use. Another thing is that you have to make the cleaning. Cleaning means that if you are working in the materials, like a cutting, so many metals are debris on your work uniform, so you need to clean by the air. So this is how we use the compressor system. Another thing is that we can also start with a very large diesel engine. Diesel engine means that when you start the diesel engine, your car is only the petrol engine. When you start the car, you have to use a motor, small motor, motor stand as a car, the piston, so that then after that you ignite, so that don't ignite, and those are in the carburetor, they miss the air and your petrol is missed and put into the car. So the after that your ignition, the ignition is slow and the piston wheels are down. So by this way you start the car. And these are different. These are you need to compress the air. Okay. All the fuels are compressed. When the fuels starts out, air is compressed. Air is compressed and then you have to ignite the fuel. So this fuel is coming into the diesel engine, so the air flow and then they will start the diesel. Yes. And we need to because we get input side. Yeah, so you have to utilize the compressor. Compressor means to compress the air. So compressor air means, so we have to the air can be taken out from the staff supply. So this is for the orifice. So we have to measure the appropriate the temperature at the orifice. So this is the hydraulic orifice system. So this is for the compressor. So this is the compressor pipe here. So this is the entry pipe. So this is air in. So this one compress. And here we use the air out. So air out with this pipe. So this one is how you measure the pressure, okay? So we usually adjust the pressure here. This point that you measure the pressure. Because this pressure is very important. So this pressure is too big or too can control, the whole system will be explode. So that this air outlet is very important. So this pressure, so this is called the pressure gauge. So this one with both here, this one with the compress. So this is the compressed air. And this one, there are the two kinds of pressure. One pressure is here. This pressure measures this gauge measures the inlet air pressure. So this one measures the outlet air pressure. So inlet air and outlet air pressure are we utilize. So this pressure measurement system compressor are also utilized in the marine diesel engine. In the marine diesel engines how we use it. Normally the marine diesels are very heavy. So you have to utilize the air pressure. So what they do is this is for the compressor. So compressor all air press and they put into this one the air reservoir. Air reservoir, this outlet bar connected to this one is the diesel engine. So this is cylinder. Air go to the diesel engine cylinder or the other air compressor system. The air pressure, so diesel engine cylinder. So this water air reservoir. So the air reservoir we compress and they put into the cylinder. So this is why we have to measure the compressor. So before the ship is start, so we have to compress the air. So the main duty engineer in the ship is we need to dry the compressor, we need to dry the oil and reservoir, everything you dry and about 2 or 3 hours before all the compressor dry and the air reservoir is filled with the air. And when we get study, normally when you fuel inject through the cylinder. So this air press the cylinder, so those cylinders moving and then we ignite the air, so fuel. So fuel with dry the engine cylinder. So this way that we run. Orifice means this is the compressor system. Compressor system means that we compress the air. So this air is also outlet from here. So this outlet we also call the orifice. So this orifice when your air is compressed, the outlet air pressure is very high. So because of this one, this orifice should be it can sometimes we go to the 3 or the sound speed, very compressed air. The compressed air they are traveling at the sound speed. And sound speed is 1,500 meter per second. So this thing will be running. And also there's so this speed depending on the shape or the type of orifice and the pressure differentiate across the orifice. So this means the inside pressure and the outside pressure they determine the outside air speed. So there are the one story that I ever heard about. So this is the air truck engineer. Air truck engineer is but this one is not a fully licensed engineer. This is just the apprentice. So his responsibility to repair the aircraft free. So aircraft. So this means before you removing the aircraft free, so Now, important thing, you have to reduce the pressure. Because this is the whole aircraft here. So this is aircraft appointment, this is tire. Okay, so I saw for the tire. The aircraft are three tire. Tire is a very compressed air. You can see that the aircraft tire is a very small size, but their inside pressure is very high pressure because of the physics. All the aircraft weight is carried by this tire. Their pressure is very high, the pressure temperature. So before that you remove the engine aircraft key or tire, first thing important is that you gradually reduce the inside the pressure. And just like the apprentice, this is the apprentice not from here. This is in Burma. The Burma this is attached to the Burma the military aircraft. So Burma Air Force this time just fellows this is new one he just open this one free without reducing the pressure as soon as we got just the whole wheels blow out and hit the face. The whole head is blow out, finish instantly die. So it can happen like this. So this is why when you use the pressure, this is inside the tire is a very high pressure. Very high pressure. If you even use take out any leak, the leakage pressure is very high. So this pressure can cause injury. So the similar thing can happen in the industry. Sometimes you are using a very high pressure system, so you never sit in front of the pressure bar. Sometimes the pressure coming out is very high, so you can you can face an injury. So this is why we study about the orifice. So this is the orifice side that determines the speed of the exit fluid. The analysis of the air. So normally the air consist of 78% nitrogen plus 20% oxygen plus and 1% argon plus 1% other gases. So this is a typical the composition of the air. Nitrogen 20%, 20% oxygen, 1% argon, and 1% other gas. So this is for the air.
Is all this calculation part of this or not?
Calculation? Yes, it's a composition. So another one will be normally the atmospheric air pressure is 101.3 kilopascal. So atmospheric pressure. 101.3 kilopascal. So this is for the compressed air pressure. So we also utilize the atmospheric pressure. So normally we can utilize the atmospheric pressure by the beacons mercury barometer. So mercury barometer is utilized to measure the atmospheric pressure. But in the industrial system, we use a special pressure gauge to measure the inside pressure of the piston. For the general measurement, so this is typical air pressure, we can utilize to measure this barometer. So this barometer this is the mercury. Mercury is this one with the atmospheric pressure. So this color of the mercury that determines the air pressure. So in this case, there will be two kinds of the pressure. One pressure is this way, this measurement. This time you use the atmospheric pressure, and this one is the gauge pressure. So the A means the atmospheric air pressure. So any pressure greater than the atmospheric air pressure is indicated by this one will fail. So in this case, you have to make the subtraction. So gauge pressure minus atmospheric pressure, that will be the so there's the absolute pressure minus the atmospheric pressure, that will be the gauge pressure. So the equation the gauge pressure is equal to absolute pressure minus the atmospheric. I write that here. The gauge pressure equal to absolute pressure minus atmospheric pressure. So the absorbing pressure minus air pressure, you can calculate the gate pressure. So this is the equation to the measure the initial pressure. So this is the fundamental of the pressure gauge. But in the industrial side, we can use the motor, electronic side, or the mechanical side. So those are the specialty side. This is the general principle. But in the air compressor, we use a special pressure gauge. But the analogy is based on this principle. In this case, how to make the analogy? So in this case, we have to, for example, air pressure is 101.3 kilopascal. So in this case, we might use a spring as a reference. So spring might provide 101.3 kilopascal. And the different pressure, we use the same pressure is overcome. So that the difference is we use indicated by the pressure indicator. So by this way you can use. You can see that this level is a air pressure. So air pressure is a 101.3. So any pressure less than the air pressure, then we use the vacuum pressure. Vacuum pressure means that any pressure less than air pressure is a vacuum pressure. So we utilize the vacuum pressure in especially the refrigeration. So when you are using in this case here, Australia is the refrigerator is no working, you throw away, you cut, then throw away another three. Someone will pick up. Sometimes thousand will pick up, no problem. But in our country, no one afford to throw away the refrigerator. If the refrigerator is not working, they bring the refrigerator to the shop. So repair shop, they have to recharge. Normally for things in the refrigerator, so there's a compressor motor. So those fellows that they cut the pipeline, they open the compressor, they take out, and inside they take out the compressor, they rewind, they put back, and after they soda again, and then after everything finished, they have to recharge the refrigeration. So what happens, what thing they do is they bring a mic. They bring a mic that all the air in all the refrigerator pipeline have to be taken out. So in this way, we use it as bacon gauge, they bring a mic. So we have to measure the gauge. So all the vacuum pressure must be less than the air pressure. And then after the vacuum mic is properly done, so they can recharge the refrigerant. They charge the refrigerant and then you measure again. So and after that they check that all refrigerant find the leakage, whether leakage or not. So sometimes they use a special equipment, but mostly they use a put the soap on the pipeline and the whether they use the pipeline, whether it's coming out, so when the air coming out, they use the bubble. The bubble and they have to use soda again. Like this they do. So this is for most of the developing countries that they repair the refrigerator by this way. This is why we have to vaporize the air. Vaporize the air means that the air in the pressure in the system must be less than the outside air pressure. So that you can put the appropriate compressive gas. Compressive gas means the refrigeration system we use the special refrigerant. Before that we use the ammonia or the freon, but we are not local for the environment, so now they use another system. So this is the way that we have to use the vacuum system. Room pressure, any pressure below the normal atmospheric pressure is termed vacuum pressure. So it can be measured with the same barometer. So we use the same barometer to measure the vacuum pressure. So in this case, so this is the level less than the atmospheric pressure is a vacuum pressure. So for the absolute zero pressure, the mercury column in the vacuum will disappear entirely. So when this means that when this becomes a vacuum here, this mercury column can disappear. When this one mercury column is a level, so you can know that this is a vacuum is falling happening. Especially in the mountain top, very high mountain, very high so the vacuum can happen. So this is the vacuum pressure measurement. So another one with the gauge pressure and the absorbing pressure the comparison. So in this case, pressure calibration based on the atmospheric pressure. So depending on the location for the sea level, the air pressure is a 101.3. This is alright. But in the mountain top, you can use the same pressure because the air pressure will be less. So that when you want to make the pressure measurement in a very high altitude, in this case you will need to regulate, calibrate your equipment. So the based on the atmospheric pressure at the display. So in this case, pressure in liquids are determined by the height of the liquid. So this means the position. This is the water fountain. So this in here pressure wave is 0. So this is 0 per meter wave. The pressure wave is 50, and this one with this wave the pressure wave is 100 like this. So this means the level. The deeper, the higher the pressure. So the depth. These are minus pressure. So in this case, like the height. So this is a depth is D. So it's proportional to the pressure. It means a depth. The deeper, the higher the pressure. So also the pressure also depending on the compression. Pressure and the compression. So this is the piston. Normally piston at this position. So then we pressure will be the pressure will be 10. Then the piston the position change to this position. So this pressure will be the 100 like this. So this is the more compression and the more pressure. So pressure depending on the height and also depending on the compression. Okay. We use the White and Charles combination law. P1 by T1 is equal to P2 by T2. So this law is utilized to calculate the pressure, volume, and the temperature. This problem. So in an air reservoir with the volume of 6 meter cube, must be filled with the compressed air to the maximum pressure of the 900 kilopascal. So in this case, in the industrial system, we use the bar unit. Bar unit means the 1 bar is equal to the 100 kilopascal. So this is the equation is 1 bar is equal to 100 kilopascal. Pascal unit is a normal unit. We use the SI unit, the pascal. But the industrial system, we use a higher unit, bar system. 1 bar is 100. Yes, pascal is very small. So this was 1 bar is 100 kilopascal. So we can utilize. Okay, so an air reservoir with the volume of 6 meter cube must be filled with the compressed air to the maximum pressure of 900 kilopascal. So this is for the reservoir. So this one is the volume V2. So volume V2, so it is a 6 meter cube. And this pressure P2 is a 9 bar or 900 kPa. This one is the reservoir. Okay, then this one is to be paid by the outside free air. So outside free air is normally 101.3 kilopascal. So this is a free air. Free air. So this one is a 101.3 kPa or 1.013 bar. So this is for the outside free air pressure P1. Pressure P1 is normal free air pressure is 101.3 or 1.013 bar. So we have to calculate the volume of air required. So in this case, we don't concern about the temperature, so that we only use the White law. White law means that P1 is equal to P2 V2. The P1 is equal to P2 V2. So outside air free air pressure is 1.013 bar. We don't know the V1. And when in the reservoir, so the volume is the pressure is a 9 bar, and V2 is a 6 meter cube. Then you can calculate the V1. So 9 multiplied 6 divided by 1.013. Then you can calculate the volume of the air requirement. So then we use the 69.3 meter cube. So the air need to be utilized to fill the compressor. A balloon is a gas volume of 2.3 meter cube, and the temperature of minus 40 degrees centigrade is heated to a temperature of 90 degrees centigrade. So why is the increased gas volume? is the pressure remain constant. So in this case, original gas volume V1 is 0.3 meter cube, and the T1 is given at the minus 14, but you have to use the absolute temperature. So you have to average the T plus 273. T1 plus 273, so this T1 is a minus 14 plus 273. So by this way you can calculate the T1. So T1 we can calculate. So that this is for the minus 14 and 273. So 273 minus 14. So that way the 259 degree Kelvin. And also in this case we have to use a gas volume. We need to calculate V2 and the temperature is 90 degrees centigrade. So T2 is 90 plus 273. So this will be 363 degree Kelvin. So in this case we have to use the equation P1 V1 by T1 is equal to T2 V2 by T2. But in this case P1 and P2 can be cancelled because the pressure remains constant. So V1 by T1 is equal to V2 by T2, and then you substitute the V1. 0 by 3 divided by T1 is 259 equal to V2, we don't know the V2, and temperature T2 is 363. And then you can calculate the V2. So that way 0.3 multiply 363 divided by 259. Then finally we got the volume of V2. The volume V2 will be the 0.74 meter, 0.14 meter cube. What the form we made a calculation. As we thought, we use the PSCCS 31 for example, that kind of system. So this will be 1A, 1N. In this case, 2A and 2N. So this one on that you want to do. So in this case, input will be 1A, 2A input, 1A and 2A, and the output